Andreoli-san です。We will now begin the afternoon session. Now, please welcome our the first presenter of the afternoon, Mr. Francesco Andreoli. Please come up to the stage.
Okay, so welcome everyone. Welcome to the survival of the lunch. So you guys have still some energy. It's great to see a bunch of folks here. So I think like my talk is all about kind of like wallets, permissionless innovation, and a bunch of things. I have 7 minutes. I don't have a lot of time. I have different kind of like slide. So let's kind of like jump in. How many developers do we have in the room? Kind of, I can fine tune a bit like the talk. Okay, a mix. But the entire talk idea is about scaling not just wallet users, getting actually like a much stronger reach around builders, developers, and one thing that a lot of people are not seeing right now, and we came out with different kind of like announcements, but we need to build also like an agentic ecosystem, meaning agentic infrastructure. And I've been working in developer relation for quite a long time, and I'm marking my 4th year at Consensus. So Consensus is the umbrella company. How many of you guys know MetaMask? So there is this umbrella company, MetaMask Infura, Linea. We recently launched the ZKVM TG. So a lot of like things are happening. I'm very passionate about privacy, open source, and open scaling. So giving instrument for developers and builders and founder to actually like build and extend the functionality of the wallet. So one of kind of like initiative that I've been helping and supporting was everything around MetaMask Naps. And we can talk a little bit about later. So the talk was about how we actually like, build features and understand which features matter the most for enhancing kind of like the user experience, the cross-chain experience for users, right? And I can talk bunch of like stuff around announcement, off-ramping, a MetaMask card, the AI kind of like announcement that we are doing with Microsoft and Google. But I want to focus on one main thing, right? I want to speak about, a very specific, sorry for the picture, one specific things about the DevRel, how we're scaling advocacy to a bigger community and bigger kind of like users, and how we can actually like build community-wide instruments that are also facilitating life of agentic ecosystem. So basically like how agent can consume information and how we can build infrastructure for future agents to scale things. And then I'm asking myself, okay, there is a lot of things happening in developer relations. We are speaking a lot of different kind of like languages. And one of kind of my focus was in order to speak the same language, we need to actually have some rules and build frameworks together. So basically kind of like things like, oh, we go to Hackathon, we're coming to EDCON, we're speaking with this XYZ amount of people. We're speaking about docs interaction. So one way to actually like give clarity is to speak with other people about the same language, and it's not just physical language, English, Japanese. It's actually speaking about the same language having frameworks. So I've been starting actually building framework for the past like year, and one of the main use case was I got inspired around 3 minutes left about snaps. So I will just go quite quickly here, but. MetaMask Naps are nothing else as kind of like a modular framework that you can extend the functionality of what MetaMask does today. There is a lot of kind of like different use case. So from interop to transaction insight to privacy. I don't know if you saw it like the Solana Snap, and further we announced Solana on natively. And there is a lot of like security and identity and attestation like snaps. Think about it as a plugin ecosystem for what MetaMask does today. So we can't scale with just technology. We need to build a framework and communities, right? So DevRel is key for doing that. So there is a lot of like different things. And I'm asking myself during this path is what actually true builders want. And I came out with this kind of like pyramid. I don't know if you remember the Maslow hierarchy of needs, came out with this kind of like pyramid of builders. So things that you need to satisfy in order to actually like build awareness around funnels and developers. Example, you need to be on the ground and activate developers and founders having access to resources need to be on point, your docs need to be on point, but you also need to build this economy for agents. I will kind of like go through, this is a quick paper, I can share it a bit later. Three lessons learned here: educate first, be authentic, and meet builders where they are. I'm throwing a bunch of kind of lessons learned during those years. So when I share these slides, also like people understand. One of the second framework that I learned was we need to teach and not shield to developers and founders. So I came out with this kind of like value-driven onboarding framework, and basically like it teaching you to actually like start with value-driven and not product-specific activations. So a lot of ways that we interacted with snaps or the stablecoin issuance, for example, was actually speak about why stablecoin are so important in the ecosystem, and then what you can build on top of it. So this was the second framework that I want to share with you guys. But then the side of the metal is that all those frameworks are for humans, right? How we actually like extend functionality for agents. We're starting to see kind of like agent consume docs. I don't know how many of you guys go through LLMs to actually like vibe coding things, but there is a lot of things that are changing in behind. We are also like, you know, mobilitating and facilitating things around docs, pre-build the repos, so things are consumable. So what humans want and what agents want, right? Agents want JSON RPCs, structured APIs, predictable schema, and a lot of like things around website are not actually satisfying that. So what we kind of like starting to think is that, okay, what are the main work streams that for DevRel are really relevant, right? So we find out these kind of like 6 things that we can actually automatize around developer relation and developer advocacy. And I came up with a third framework, and this is kind of like the last of the day in this kind of like 7 minutes, extremely fast talk. This was kind of like a 1 hour plus. But basically, a bunch of these work streams cannot really fully agent native automatize. It's a progress, right? So how I kind of define this automation of processes: human-led, assistant-led, and agent native. So a bunch of things. I need to wrap up, guys, but I can share this slide a little bit later. And I just want to say, all this future innovation need to satisfy both humans and agents. We need to make sure that we are not kind of like falling behind, especially with our documentation and apps. And I want to finish with this, you know, will Wallet kind of take our job, our human-empowered agents? So basically, we will be out of our job, and this is a funny kind of like things I saw. They don't appear to want to take over, they just want to dance. So thank you so much, EDCON, for this quick lightning talk, and a big pleasure to be here.
Thank you very much. ありがとうございました。では続いてのプレゼンターご紹介いたしましょう。次はダニエル・エクスポネンツさんです。Next, we'd like to invite our next speaker, Mr. Daniel Exponents. Mr. Daniel, the floor is yours.
Testing 1, 2, 3. All right. I have 20 minutes. I could have given a few to Francesco, but we'll have to get through it. So thanks everyone for joining after lunch. I hope it's recorded because some people are not here. So today I'll show and present both the rational motivation behind building the satellite expansion of the world computer. As some of you know, Ethereum is the world computer, so we're building an expansion of it in space, as well as go a little bit into how we're building the space computer stack. So very quick, brief history of compute stack as a whole. So originally, when compute started being developed as a mechanical or automated operation, it was still task specific, and you had computers that were entire rooms dedicated to a single computer that doesn't even do general purpose compute, it does just task specific. This is, I think, an image from the Bletchley Labs. And not long after, Alan Turing came up with this concept of general purpose compute. So he basically took the rationale of using in those years electromechanical components to execute compute. The motivation behind his invention was to crack the Enigma code and win the Second World War. But I think that as a mathematician, a part of his motivation was to introduced this concept of general purpose compute, so essentially something that can be used for any piece of code, hypothetically. Then what further scaled this whole compute revolution was the invention of the solid-state transistors. So solid-state transistors allowed the miniaturization, the race to pack more and more transistors onto chips, and now we basically have like billions and billions of transistors in our pockets, and Moore's law is kind of getting to its limits, but yet we're inventing new generations of transistors. Afterwards came the high-level programming languages, which enabled people to not even have to be aware of how the actual compute happens at the machine level, and they could just write scripts, which is what we're doing today, and ultimately the graphic user interfaces and OSs, which is essentially like you don't even need to know that there is a code. You just click stuff and interact with it in the same way that you do things in life outside of compute. And then came the internet. This is two anecdotal moments of history from the internet. One is the IRC chats. Another one is, at the time, the leaked video from Pamela Anderson and Tommy Lee that became overnight the most viewed video in history at the time. And it kind of demonstrated the power of both the fact that compute systems became commercially available and ubiquitous, as well as the interconnectivity suddenly unleashed commercial applications that we just didn't foresee happening before. Definitely Alan Turing didn't envision that this would be the first application for the compute, I imagine. And over time, we became really good at digitizing trusted parties, which is already going towards the crypto side of things. So we essentially started having systems that provide us services, whether it's banking services, whether it's eventually e-commerce, social networks. And then rather than having to run servers on our own or operate website and offer services on our own in servers at home, we basically could rely on those very convenient entities that provide us with specific applications. But this also meant that we have a centralized trusted party. It was all looking good, right? Until it didn't. And basically, that was kind of the call to action to start what today we call crypto. That's the famous quote that is in the Bitcoin Genesis block, where the chancellor is on the brink of second bailout for banks. And essentially, then we go into a new rabbit hole of compute stack, which is the crypto-economic compute systems. And crypto-economic compute system, essentially it's trusted party, except it's distributed. It's no longer a centralized trusted party. And then it's on top of that, it's a computer. Rather than having a server that is the computer, we have a distributed network that functions as one unified computer. So let's take a quick look at the timeline of innovation in the distributed computer stack and how the trusted party served there. The first one was Bitcoin, obviously. Bitcoin was supposed to be a task-specific computer with a single application being money, so peer-to-peer electronic cash system. Nowadays, as we know, nobody really uses it for payments, but it landed on the use case of store of value. So today, Bitcoin essentially is a task-specific computer for gold, digital gold. Afterwards, there was some a bit more avant-garde and innovative approach, so similar to the concept of expanding from task-specific, Vitalik came with the idea of expanding the distributed computer into a general-purpose computer with Ethereum, so essentially a Turing-complete distributed computer environment. And we have all of the wonderful miracles that we're using today, whether it's DeFi, DAOs, NFTs, and all the shenanigans. And interestingly, since Ethereum, actually there wasn't something really novel that was invented, right? Like if it's the new networks that we're seeing out there, typically all that they tout is that they're faster or they're cheaper or there's better casino application on them. But actually there's nothing really new, right? Nothing fundamentally new. So to that, 4 of the areas that I believe are massively under-addressed in crypto, privacy, which we'll talk about after this talk in a short panel. Inclusion, so essentially accessibility to the frontier of global innovation and the economy for areas that cannot otherwise participate. Resilience, so whether it's resilience from a game theoretic point of view, or if it's resilience from attacks and hardware vulnerabilities, etc. And then security, which kind of relates to it. Those are areas that are massively under addressed, and we always hear about edge cases where they are constantly being exploited. So the question is the world computer the final frontier, or do we have more to explore? And my argument is that the next frontier is the reacceleration of the space race. So if we're looking at only in the last 2 years or so, we launched more satellites into orbit than in the entire 50 years combined of previous century. So essentially, there's more and more satellites being launched, more and more applications being uncovered. And with the talk of Starship, recently we had the experiment of, what was it called? Splashdown, I think, where they demonstrated recovering some of the boosters or what. We're talking about expansion of the payloads of more than 400 times, so like orders of magnitude. And that means that the launch cost is going to be converging to something like tens of dollars per kilogram. So that means it's no longer something like space as a domain is no longer only relevant for state-level actors. It's something that a couple of people in a co-working space can start looking at building for space, right? So a lot of new innovation is going to be unlocked in the space frontier. And some of the things that we're already familiar with, so whether it's GPS that everyone uses today, whether it's for location-based services and applications on your mobile, remote connectivity, so Starlink, Iridium. Personally, I live in a remote region and I rely on those services in order to connect to the internet. And by virtue of having those services, you suddenly have the remote regions of the world connected in a competitive way to the economy. Starlink in 2024 launched 7,000 or more than 7,000 satellites, which in history, it's basically unimaginable numbers, and these numbers are only growing. We're looking at probably quadrupling it over the next few years. Planet Labs is basically already a very widely used service for different, whether it's governments or supply chain applications. So you see that more and more the space domain is becoming important for the economy. Now, how can the world computer concept be expanded beyond the bound of Earth? So these are some of the some of the examples we're working on in Space Computer, working with developers to use cosmic radiation as a source for randomness. So randomness beacon based on true cosmic radiation. And one example is a password generator, another one is a raffle, so essentially a kind of a lottery. And yeah, I'll go now into some details of how we're building the space computer and what is the space computer. So space computer in a nutshell is a high security guarantees based on physical isolation. So essentially you have a tamper resistance computers aboard satellites that each of them serves as a space TE. TE stands for Trusted Execution Environment, and eventually we'll build a node network based on them. So what is space computer in a nutshell? It's a robust layer 1 in space, a network of those space TE nodes that is supporting smart contract and ultimately aims to serve as a marketplace for payments and for satellite services. Now, taking a little bit of a deeper look on where we're at, today we have already access to one satellite, so we're starting to look at a single node, and single node that functions as a TE. For those that are less familiar with TE, the rationale is that you have a secure environment separate to the typical CPU, and this secure environment can also remain secure even if the hypervisor is hypothetically malicious. And what we have today is that you're interfacing to the satellite via a space compute gateway. So if we're looking at it, you have services that support users on Earth with high security guarantees, whether it's for the layer 1s, the layer 2s, and then ultimately looking at relying on more than one communication provider. So it can be abstracted whether it's interfacing to Starlink or to Iridium or to anything else, and essentially you can look at it as some kind of RPC aggregator for space gateway. Yeah, so OrbitPort is currently the somewhat hosted service that we're operating, with applications being the cosmic true random number generator and eventually expanding to more features. And ultimately, we want to turn it into something more trust minimized than being hosted and operated by us. So that means that we'll look at multi-node, essentially moving to a network constellation that consists of those services, each satellite services, whether it's randomness, whether it's MPC, so that satellites can be signers in a threshold scheme. And yeah, each of them essentially functions as a TE. To scale that, we'll be looking at either the optimistic or the ZK rollups. So obviously there's trade-offs with each of them, but a part of building that stack will rely on those existing components that we're familiar with from today, how Ethereum L2s function. Essentially, the L1 in orbit is somewhat of a capacity-constrained network like Bitcoin. And then in order to augment the performance, we're looking at using the similar technologies that we have today for the Ethereum network. And some rationale for how it works. So we basically have here an example of relying on the satellites from a company called Aptos Orbital for the randomness, and then a user essentially interfaces to those satellites via the OrbitPort Space Compute Gateway, and then the actual randomness is being fed through the gateway, and the application is consumed here on Earth. I guess I have not so much time. Quickly on OrbitPort as the gateway for space compute, we're currently enabling the CTRNG. Ultimately, we'll look at custodial wallets, and then some of the interesting applications for people were network state. So imagine that you have DAOs that are domiciled outside of legacy nation states. Essentially, you don't have a country host for a jurisdiction. Or you have a programmable cryptography toolkit that you're able to interact with that would be deploying contracts directly on satellite. And then eventually, once you have a full constellation, you can start looking at bridging all compute services from different satellites. These are some of the applications, so whether it's space vaults, DeFis and DAOs that are running on satellite I mentioned, and programmable cryptography. Some of the roadmaps, so with one satellite today, we're soon completing the specification for the protocol, so we'll be looking at how to actually operate a consensus and execution clients aboard the satellite, then build the Earth component stack for interfacing to it from Earth. Ultimately scale it with the L2s, AVSs, and then eventually work towards the constellation that would enable the full space TE network. And yeah, with that, if you want to connect and you're interested, please reach out. I'll be here for the rest of the couple of days. Cheers. Do we have time for questions, or it's not the... All right.
You have some more time.
So any questions? Not much. Okay, we can just move to the panel then.
Thank you very much. ありがとうございました。では続いて